Welcome to the Bricklayer Red Seal exam practice. This video contains 125 practice questions to help you prepare for your certification exam. Let's begin. This exam covers the following major work activities: common occupational skills, general masonry practices, masonry systems, natural stone systems, chimneys and fireplaces, and 3 more areas. Question 1. What is the primary purpose of conducting a site-specific hazard assessment before beginning masonry work? A. To determine the total quantity of masonry units required for the project. B. To identify potential hazards and establish appropriate control measures. C. To calculate the labor hours needed to complete the masonry installation. D. To establish the delivery schedule for masonry materials and equipment. The correct answer is B. To identify potential hazards and establish appropriate control measures. A site-specific hazard assessment identifies potential hazards such as fall risks, silica dust exposure, overhead power lines, and trench collapses before masonry work begins. This allows the implementation of appropriate control measures including engineering controls, administrative controls, and personal protective equipment requirements. Provincial occupational health and safety regulations require hazard assessments to be completed prior to starting construction work. Question 2. When a bricklayer discovers an unprotected floor opening near their work area on a construction site, what is the correct first action? A. Continue working and mention the hazard at the next scheduled safety meeting. B. Place a single pylon near the opening and resume the masonry installation work. C. Immediately secure the area, warn nearby workers, and report to the supervisor. D. Document the hazard in the daily logbook and continue with the current task. The correct answer is C. Immediately secure the area, warn nearby workers, and report to the supervisor. When a bricklayer discovers an unprotected floor opening, they must immediately secure the area to prevent falls, warn nearby workers of the hazard, and report the condition to the supervisor for corrective action. Under provincial occupational health and safety legislation, all workers have a duty to report unsafe conditions immediately rather than waiting for scheduled meetings or relying on minimal controls like a single pylon. Question 3. What is the correct procedure for controlling silica dust exposure when cutting masonry units on a construction site? A. Use wet cutting methods or local exhaust ventilation with respiratory protection. B. Apply a dust mask and cut units indoors where wind will not spread particles. C. Cut all masonry units at the end of the shift when fewer workers are nearby. D. Position the cutting station downwind from other workers on the project site. The correct answer is A. Use wet cutting methods or local exhaust ventilation with respiratory protection. Controlling silica dust exposure requires using wet cutting methods or local exhaust ventilation systems combined with appropriate respiratory protection such as a half-face respirator with P100 filters. Cutting indoors concentrates airborne dust, scheduling cuts for end of shift does not eliminate exposure, and positioning downwind does not protect the operator. Canadian occupational health and safety regulations specify these engineering controls as the primary defense against respirable crystalline silica. Question 4. What is the correct method for maintaining a masonry trowel to ensure consistent mortar application? A. Clean mortar residue promptly after use and apply light oil to prevent rust. B. Soak the trowel blade in water overnight to loosen any dried mortar buildup. C. Sand the blade surface with coarse grit sandpaper to restore the working edge. D. Sharpen the blade edge using a bench grinder to maintain the factory bevel. The correct answer is A. Clean mortar residue promptly after use and apply light oil to prevent rust. Proper trowel maintenance involves cleaning mortar residue promptly after each use and applying a light coating of oil to prevent rust and corrosion. Soaking overnight can damage the handle and cause pitting. Sanding with coarse grit removes the tempered surface. Grinding alters the blade geometry and removes material unnecessarily. Regular cleaning and oiling extends tool life and maintains the smooth surface needed for consistent mortar application. Question 5. When using a forklift to transport a palletized load of bricks on a construction site, what is the correct operating procedure? A. Raise the forks to maximum height while traveling to clear ground obstacles. B. Travel with the load tilted back and forks lowered to maintain stability. C. Allow workers to ride on the forks beside the load to guide it into position. D. Approach the unloading area at full speed and brake sharply for positioning. The correct answer is B. Travel with the load tilted back and forks lowered to maintain stability. The correct procedure for transporting a palletized load of bricks with a forklift is to travel with the load tilted back and the forks lowered approximately 15 to 20 centimeters above the ground surface. This position maintains the forklift's center of gravity and stability while providing adequate ground clearance. Raising forks high creates tip-over risk, carrying riders on forks is prohibited, and sharp braking can cause the load to shift or fall. Provincial occupational health and safety regulations govern forklift operation on construction sites. Question 6. What is the correct procedure for determining the sling configuration when lifting a crate of masonry lintels with a crane? A. Estimate the load weight visually and select the nearest available sling size. B. Choose the longest sling available to maximize the lifting angle for the load. C. Verify the load weight, check sling capacity charts, and ensure a safe sling angle. D. Attach the slings vertically to a single lifting point at the center of the crate. The correct answer is C. Verify the load weight, check sling capacity charts, and ensure a safe sling angle. The correct procedure requires the rigger to verify the actual load weight from shipping documents or by calculation, consult the sling manufacturer capacity charts for the sling type and configuration, and ensure that the sling angle does not reduce capacity below the load weight. Visual estimation is unreliable and dangerous. Longer slings at shallow angles reduce capacity. A single attachment point risks unbalanced loads. Provincial occupational health and safety regulations and rigging standards mandate these procedures for crane lifts. Question 7. According to Canadian scaffold safety standards, when must a frame scaffold be tied into the building structure? A. Only when the scaffold exceeds 15 meters in total height on any project. B. Tie-ins are required at every second frame level regardless of the height. C. When the scaffold height exceeds 3 times its minimum base dimension. D. Only when the scaffold is erected on soft ground without concrete footings. The correct answer is C. When the scaffold height exceeds 3 times its minimum base dimension. Canadian scaffold safety standards require that a frame scaffold be tied into the building structure when its height exceeds 3 times its minimum base dimension, the 3-to-1 height-to-base ratio. This prevents lateral instability and overturning. Additional tie-ins are required at vertical intervals specified by provincial occupational health and safety regulations, typically every 9 meters for the first tie and every 6 meters thereafter. The 3-to-1 rule applies regardless of ground conditions or project type. Question 8. What is the correct sequence for erecting a frame scaffold for a masonry project on level ground? A. Install planking on the first level, then set frames on top, add braces last. B. Place mud sills randomly, set frames, then adjust for level after full erection. C. Erect all frames first to full height, then install cross braces top downward. D. Place mud sills on firm ground, set screw jacks, install frames, add cross braces. The correct answer is D. Place mud sills on firm ground, set screw jacks, install frames, add cross braces. The correct erection sequence begins with placing mud sills on firm, level ground to distribute the scaffold load, followed by setting screw jacks on the sills for fine leveling, then installing the first pair of frames plumb and level, and adding cross braces to lock the assembly. Each subsequent lift follows the same pattern. Installing planking before frames reverses the sequence. Random placement of mud sills and post-erection leveling compromise structural integrity. Erecting all frames without progressive bracing risks collapse. Question 9. When dismantling a frame scaffold, what is the correct procedure to ensure worker safety throughout the process? A. Remove all planking from every level first before dismantling frames or braces. B. Lower all scaffold components to the ground using a garbage chute or channel. C. Dismantle from the top level down, removing planks, braces, and frames in order. D. cut the cross braces with a reciprocating saw to speed up the dismantling work. The correct answer is C. Dismantle from the top level down, removing planks, braces, and frames in order. Scaffold dismantling must proceed from the top level downward, removing components in the reverse order of erection, planking first, then cross braces, then frames at each level. This maintains structural stability throughout the process. Removing all planking first eliminates safe working platforms for workers dismantling the upper levels. Garbage chutes are not designed for scaffold components. Cutting cross braces destroys reusable materials and creates uncontrolled hazards. Provincial occupational health and safety regulations mandate reverse order dismantling by competent workers. Question 10. A bricklayer is reviewing architectural drawings for a new brick veneer wall. Which information is most critical to verify before starting the layout? A. The exact name and contact details of the project architect in the title block. B. Wall dimensions, bond pattern, control joint locations, and flashing details. C. The revision history table to check how many drawing changes were issued. D. The general notes section specifying contractor insurance and bonding amounts. The correct answer is B. Wall dimensions, bond pattern, control joint locations, and flashing details. Before starting a brick veneer wall layout, the bricklayer must verify the wall dimensions for accurate coursing, the specified bond pattern for unit arrangement, control joint locations for crack control, and flashing details for moisture management. These elements directly affect material ordering, layout spacing, and construction sequence. Architect contact information, revision history, and insurance details are administrative items that do not impact the physical layout of the masonry work. Question 11. When planning daily masonry tasks, what factor should a bricklayer consider first to prevent delays during the work shift? A. The personal preferences of each team member regarding their task assignments. B. The color selection of mortar dies for the specified architectural joint finish. C. Weather conditions, material availability, and equipment readiness for the work. D. The estimated completion date of adjacent trades not yet scheduled to start. The correct answer is C. Weather conditions, material availability, and equipment readiness for the work. Effective daily planning requires the bricklayer to first assess weather conditions, temperature, wind, and precipitation affect mortar performance, confirm material availability, bricks, mortar, sand, and reinforcement on site, and verify equipment readiness, mixer, scaffolding, and cutting equipment operational. These factors directly determine whether productive masonry work can proceed. Personal preferences, mortar die selection, and other trade schedules are secondary considerations that do not prevent the day's work from starting. Question 12. What is the primary purpose of protecting surrounding areas and completed work when preparing a masonry job site? A. To reduce the total amount of cleanup materials required at the end of each day. B. To prevent other trade workers from accessing the scaffolding during off hours. C. To prevent damage from mortar splatter, debris, and moisture on finished surfaces. D. To minimize the insurance liability claims associated with stored building materials. The correct answer is C. To prevent damage from mortar splatter, debris, and moisture on finished surfaces. Protecting surrounding areas during masonry work prevents damage from mortar splatter, falling debris, and moisture intrusion on adjacent finished surfaces such as windows, flooring, completed drywall, and landscaping. Drop cloths, poly sheeting, and protective boarding are used to shield vulnerable areas. This protection reduces costly repairs and delays caused by damage to other trades' completed work. The building codes and project specifications typically require protection of adjacent work during masonry operations. Question 13. A bricklayer notices that a new apprentice is consistently spreading mortar too thin on bed joints, resulting in weak bond strength. What is the most effective approach to address this? A. Demonstrate the correct mortar thickness and buttering technique, then observe their work. B. Report the apprentice to the general contractor and request a crew replacement immediately. C. Allow the apprentice to continue and correct all the deficient joints at the end of the day. D. Assign the apprentice to cutting and material handling duties until their next class session. The correct answer is A. Demonstrate the correct mortar thickness and buttering technique, then observe their work. The most effective approach is to demonstrate the correct mortar thickness, typically 10 mm for bed joints, and proper buttering technique, then observe the apprentice's work and provide immediate constructive feedback. This hands-on mentoring approach addresses the root cause by building the apprentice's skill. Reporting for replacement does not develop the apprentice. Allowing deficient work to continue wastes materials and creates structural concerns. Removing the apprentice from laying duties delays their skill development. Question 14. An experienced bricklayer is mentoring a second-year apprentice who is struggling with laying units to a consistent line and level. What mentoring strategy would be most effective? A. Break the skill into smaller steps, demonstrate each one, then gradually increase complexity. B. Complete the task for the apprentice and have them only observe until they feel confident. C. Assign the apprentice to only mix mortar until their hand-eye coordination improves. D. Provide written instructions for the task and allow the apprentice to practice unsupervised. The correct answer is A. Break the skill into smaller steps, demonstrate each one, then gradually increase complexity. Breaking a complex skill into smaller steps, demonstrating each component, and gradually increasing the complexity is the most effective mentoring strategy for skill development. This scaffold approach allows the apprentice to build confidence with individual elements, string line setup, mortar spreading, unit placement, level checking, before combining them. Simply observing does not build hands-on skill. Restricting the apprentice to mortar mixing delays development. Unsupervised practice without demonstration risks reinforcing incorrect techniques. Question 15. What is the primary purpose of preparing a vertical substrate before installing brick veneer on a wood frame wall? A. To reduce the overall weight of the masonry veneer system on the wall framing. B. To provide a clean, plumb surface for proper attachment of ties and flashing. C. To eliminate the requirement for expansion joints in the completed brick veneer. D. To increase the thermal mass of the wood frame wall for energy code compliance. The correct answer is B. To provide a clean, plumb surface for proper attachment of ties and flashing. Preparing the vertical substrate provides a clean, plumb surface that is essential for proper attachment of wall ties and correct placement of flashing. A substrate that is dirty, uneven, or out of plumb will compromise the tie connection strength and prevent flashing from directing moisture properly. Masonry construction standards requires that backup walls be plumb and clean before masonry veneer installation begins. Question 16. What is the correct procedure for preparing a concrete foundation ledge before laying the first course of masonry units? A. Apply a bonding agent to the ledge surface and begin laying while the agent is wet. B. Clean the ledge of debris, dampen the surface, and snap a layout line for alignment. C. Score the foundation surface with a chisel at 25 mm intervals to improve the grip. D. Apply a thick layer of Type M mortar and let it set for 24 hours before laying units. The correct answer is B. Clean the ledge of debris, dampen the surface, and snap a layout line for alignment. Proper foundation ledge preparation requires cleaning all debris, dirt, and loose material from the surface, dampening the concrete to prevent it from drawing moisture out of the mortar too quickly, and snapping a chalk line or laser line to establish a straight reference for the first course alignment. This ensures proper mortar bond and accurate wall placement. Masonry construction standard specifies substrate preparation requirements for masonry bearing surfaces. Question 17. What is the correct application method for parging a below-grade concrete block foundation wall? A. Apply a single thick coat of mortar in one pass and allow it to air dry completely. B. Mix the parging mortar with extra water to create a thin slurry for easy application. C. Apply the parging mix only above the finished grade line where the surface is visible. D. Dampen the wall, apply parging in 2 coats, and keep each coat moist while curing. The correct answer is D. Dampen the wall, apply parging in 2 coats, and keep each coat moist while curing. Below-grade parging requires dampening the block wall first to ensure good bond, then applying 2 coats of parging mortar, each approximately 6 to 10 mm thick. Each coat must be kept moist during curing to develop proper strength and prevent cracking from rapid moisture loss. A single thick coat will shrink and crack. Extra water weakens the mix. Parging must extend below grade for moisture protection as specified in building codes. Question 18. What type of mortar mix is typically used for parging a foundation wall in Canadian residential construction? A. A Type O mortar mix designed for interior non-load-bearing partition wall joints. B. A Type S mortar mix with an acrylic additive for improved flexibility below grade. C. A standard concrete mix with large aggregate for maximum compressive strength only. D. An acid-resistant mortar mix designed for industrial chimney lining and stack work. The correct answer is B. A Type S mortar mix with an acrylic additive for improved flexibility below grade. Type S mortar with an acrylic additive is typically used for foundation parging in Canadian residential construction. Type S provides high compressive strength and good bond for below-grade applications, while the acrylic additive improves flexibility, adhesion, and resistance to cracking from freeze-thaw cycles. Type O is too weak for below-grade use. Standard concrete with large aggregate is not suitable for thin parging applications. Mortar and Grout Standard specifies mortar types for various masonry applications. Question 19. When installing adjustable wall ties to connect brick veneer to a wood frame backup wall, what is the correct spacing? A. One tie per masonry unit at every course along the full height of the veneer wall. B. Ties placed only at window and door openings where the veneer requires lateral bracing. C. A maximum of 600 mm horizontally and 400 mm vertically with ties staggered per course. D. A minimum of 900 mm horizontally and 600 mm vertically to reduce wall penetrations. The correct answer is C. A maximum of 600 mm horizontally and 400 mm vertically with ties staggered per course. Masonry Construction Standard specifies that adjustable wall ties connecting brick veneer to a wood frame backup must be spaced at a maximum of 600 mm horizontally and 400 mm vertically, with ties staggered between courses for uniform load distribution. One tie per unit is excessive and unnecessary. Placing ties only at openings leaves large unsupported areas. A 900 mm by 600 mm spacing exceeds the maximum permitted and would not provide adequate lateral support for the veneer width. Question 20. Which type of wall tie is most commonly specified for connecting brick veneer to a concrete masonry backup wall? A. Wire ladder type horizontal joint reinforcement embedded in the mortar bed joints. B. Plastic snap ties typically used for concrete formwork and temporary wall bracing. C. Self-tapping metal screws driven directly through the veneer into the backup width. D. Adjustable two-piece wall ties with a plate anchor and an iron pintle connector. The correct answer is D. Adjustable two-piece wall ties with a plate anchor and an iron pintle connector. Adjustable two-piece wall ties with a plate anchor embedded in the backup wall mortar joint and an iron pintle connector are most commonly specified for brick veneer on concrete masonry backup. The adjustable design accommodates differential movement and coursing variations between the veneer and backup widths. Wire ladder reinforcement provides horizontal reinforcement but not inter-width connection. Plastic snap ties are for concrete formwork. Direct screws would crack masonry units. Masonry Construction Standards governs wall tie selection and installation. Question 21. What is the correct procedure for installing through-wall flashing at the base of a brick veneer cavity wall? A. Extend the flashing from the backup wall face through to the exterior with a drip edge. B. Install the flashing flat without any slope and seal both edges with masonry caulking. C. Place the flashing below the first course only if the wall exceeds 3 stories high. D. Embed the flashing entirely within the mortar bed without extending past the wall face. The correct answer is A. Extend the flashing from the backup wall face through to the exterior with a drip edge. Through-wall flashing at the base of a cavity wall must extend from the backup wall face, across the cavity, and through to the exterior face of the veneer with a drip edge that directs collected moisture outward. Flat installation without slope allows water to pond. Flashing is required at the base regardless of building height. Embedding the flashing without an exterior extension traps water inside the wall. Building codes and masonry construction standards specify flashing requirements for cavity wall construction. Question 22. In Canadian masonry construction, what is the standard planning module used for laying out brick veneer walls? A 100 mm module based on one brick width plus a standard 10 mm mortar joint. B. A 200 mm module where one stretcher length plus one 10 mm head joint equals 200 mm. C. A 150 mm module based on two brick heights plus two standard mortar bed joints. D. A 300 mm module based on three brick lengths plus three 10 mm mortar head joints. The correct answer is B. A 200 mm module where one stretcher length plus one 10 mm head joint equals 200 mm. The standard planning module for Canadian brick masonry is 200 mm. One standard modular brick stretcher has an actual length of 190 mm, and when combined with one 10 mm head joint, the total equals 200 mm. This 200 mm module simplifies layout calculations and coordinates brick coursing with other building dimensions. Vertically, 3 courses of standard modular brick, each 57 mm plus a 10 mm bed joint, also equal approximately 200 mm. Brick dimension standards define standard brick dimensions used in Canadian construction. Question 23. What is the correct method for maintaining a running bond pattern when turning a brick wall at an outside corner? A. Start every course with a full stretcher on both faces of the corner joint line. B. Alternate courses so the lead brick on each face offsets the course below by half. C. Insert a queen closer adjacent to the corner unit on every second course laid. D. Cut a 45-degree miter on the corner bricks to create a seamless outside edge. The correct answer is B. Alternate courses so the lead brick on each face offsets the course below by half. Maintaining running bond at an outside corner requires alternating courses so the lead brick on each face offsets by half a brick length from the course below. On one course the full stretcher leads on face A, and on the next course the full stretcher leads on face B. This staggers the vertical head joints by half a unit on both wall faces and creates the interlocking corner pattern. Starting every course identically would stack head joints. A queen closer is used for Flemish bond corners. Mitered corners are not standard practice for running bond. Question 24. When using a story pole to verify masonry coursing, what measurement should the bricklayer check at each control point? A. The cumulative course height to confirm it matches the story pole marks at that level. B. The individual thickness of each mortar bed joint measured with a steel tape measure. C. The horizontal spacing between head joints on every third course of the brick veneer. D. The diagonal measurement from corner to verify the wall is plumb and square. The correct answer is A. The cumulative course height to confirm it matches the story pole marks at that level. A story pole, also called a gauge rod or course rod, has marks at predetermined course heights. The bricklayer checks the cumulative course height at each control point, such as window sills, lintels, and floor lines, to confirm that the coursing matches the story pole marks and will align with architectural features. Checking individual joint thickness does not verify cumulative accuracy. Horizontal head joint spacing and diagonal measurements serve different layout purposes not related to vertical coursing control. Question 25. What is the correct procedure for laying out the first course of bricks to establish proper head joint spacing? A. Begin at one end and work toward the other, cutting the last brick to fit the space. B. Dry lay the first course without mortar, adjusting head joints to minimize brick cuts. C. Start from the center of the wall and work outward toward both ends at the same time. D. Set every brick with a fixed 10 mm head joint regardless of the overall wall length. The correct answer is B. Dry lay the first course without mortar, adjusting head joints to minimize brick cuts. Dry laying the first course without mortar allows the bricklayer to adjust the head joint spacing slightly, within an acceptable range of 8 to 12 mm, to minimize the number of cut bricks needed at openings, corners, and wall ends. This produces a cleaner appearance and reduces material waste. Starting from one end with no adjustment usually results in an awkward cut at the other end. Working from the center is not standard practice. Fixed 10 mm joints without adjustment may not accommodate the actual wall length. Question 26. Which mortar joint profile provides the best weather resistance for exterior masonry walls exposed to driving rain? A rake joint where mortar is scraped back to create a recessed shadow line effect. B. A flush joint where mortar is cut level with the face of each masonry unit on the wall. C. A struck joint where the mortar slopes inward from the top edge of the lower unit. D. A concave joint tooled with a round jointer that compresses and seals the mortar face. The correct answer is D. A concave joint tooled with a round jointer that compresses and seals the mortar face. A concave joint tooled with a round jointer provides the best weather resistance because the tooling action compresses and densifies the mortar surface, closing voids and creating a curved profile that sheds water away from the joint. Rake joints expose the mortar to direct water entry. Flush joints lack the compression that seals the surface. Struck joints slope inward at the top, directing water into the joint rather than away from it. Masonry construction standards recommends concave or V-joints for exterior masonry exposed to weather. Question 27. At what stage of mortar curing should the bricklayer begin tooling the mortar joints for a concave finish? A. When the mortar is thumbprint firm, holding shape when pressed but not hardened. B. Immediately after placing each brick unit while the mortar is still fully wet. C. After the mortar has reached full strength, typically 24 to 48 hours after laying. D. Only after the entire wall section is completed and all courses are laid in place. The correct answer is A. When the mortar is thumbprint firm, holding shape when pressed but not hardened. Mortar joints should be tooled when the mortar has reached a thumbprint firm consistency, meaning it holds its shape when pressed with a thumb but has not yet hardened. At this stage the jointer can compress and smooth the mortar surface effectively. Tooling too early when the mortar is fully wet will drag and smear the joint. Tooling after full cure will not allow the jointer to compress and seal the surface. Waiting until the entire wall is complete means early joints will have hardened past the optimal tooling window. Question 28. What is the correct sequence for tooling horizontal bed joints and vertical head joints to achieve a consistent finish? A. Tool all joints at once by pressing the jointer diagonally across the wall face. B. Apply additional wet mortar over each joint before tooling to fill any surface voids. C. Tool the head joints first, then run the jointer along the bed joints for clean lines. D. Use a flat pointing trowel to press the mortar flush before using a round jointer. The correct answer is C. Tool the head joints first, then run the jointer along the bed joints for clean lines. The correct sequence is to tool the vertical head joints first, then tool the horizontal bed joints. This order ensures that the bed joint jointer creates a clean, continuous horizontal line that neatly crosses over the already tooled head joint ends, producing a consistent finished appearance and better weather resistance at the intersections. Diagonal tooling does not produce clean joints. Adding wet mortar creates inconsistent color. Flushing before tooling adds an unnecessary step and alters the profile. Question 29. What is the recommended minimum waiting period before cleaning a new brick wall with a dilute muriatic acid solution? A. Cleaning can begin immediately after the last brick is laid to minimize staining. B. A minimum of 7 days to allow the mortar joints to cure and gain enough strength. C. A minimum of 48 hours provided the mortar has dried to a uniform light gray color. D. A minimum of 28 days, matching the full curing period required for poured concrete. The correct answer is B. A minimum of 7 days to allow the mortar joints to cure and gain enough strength. A minimum waiting period of 7 days is recommended before acid cleaning new brick masonry. This allows the mortar joints to cure sufficiently so that the acid solution does not etch or damage the mortar. Immediate cleaning while mortar is fresh will dissolve and weaken the joints. A 48-hour wait is insufficient for adequate mortar cure. While 28 days is the full cure period for Portland cement products, 7 days provides adequate strength for acid cleaning. The Brick Industry Association recommends this minimum waiting period. Question 30. What is the correct procedure for cleaning new brick masonry walls using a diluted muriatic acid solution? A. Apply the acid solution directly to the dry wall surface and scrub with a wire brush. B. Spray undiluted acid across the entire wall face and rinse it with a pressure washer. C. Soak the wall with acid overnight to dissolve all mortar smears and rinse next morning. D. Pre-wet the wall, apply diluted acid solution in small sections, then rinse thoroughly. The correct answer is D. Pre-wet the wall, apply diluted acid solution in small sections, then rinse thoroughly. The correct acid cleaning procedure requires pre-wetting the wall thoroughly to prevent the acid from being absorbed deeply into the brick or mortar, then applying a properly diluted muriatic acid solution, typically 1:10 ratio, to small manageable sections, scrubbing with a stiff bristle brush, and rinsing thoroughly with clean water before moving to the next section. Applying acid to a dry wall causes deep penetration and staining. Undiluted acid damages both brick and mortar. Overnight soaking causes severe acid damage. Question 31. A bricklayer applies a muriatic acid solution to a new concrete block wall and notices green staining on the surface. What is the most likely cause? A. The mortar joints were not fully cured before the acid cleaning solution was applied. B. Muriatic acid reacted with manganese compounds in the concrete masonry units. C. The acid solution was applied to the wall surface without adequate pre-wetting first. D. The muriatic acid concentration was too dilute to properly dissolve the mortar smears. The correct answer is B. Muriatic acid reacted with manganese compounds in the concrete masonry units. Green or brown staining on concrete masonry units after acid cleaning is caused by a chemical reaction between the muriatic acid, hydrochloric acid, and manganese dioxide compounds present in the concrete mix. The reaction produces manganese chloride, which appears as a green or brown stain on the block surface. This is why muriatic acid should generally not be used on concrete masonry units. Instead, proprietary concrete block cleaners or mild detergent solutions should be used for cleaning concrete block walls. Question 32. What is the correct procedure for mixing mortar in a mechanical drum mixer for bricklaying operations? A. Add all dry ingredients and water simultaneously to the rotating drum to save time. B. Add most of the water first, then sand and cement gradually while the drum rotates. C. Place all dry ingredients into the drum first, then add the total water all at once. D. Mix the cement and water into a paste first, then add sand incrementally to the mix. The correct answer is B. Add most of the water first, then sand and cement gradually while the drum rotates. The correct mixing procedure is to add approximately 3/4 of the required water to the rotating drum first, then gradually add the sand and cement, or pre-blended mortar mix, while the drum rotates. The remaining water is added last to adjust the mortar to the desired consistency. This sequence ensures thorough blending and prevents dry pockets. Adding everything at once or all dry materials first results in poor mixing and clumping. Cement paste first can leave unmixed sand pockets. Mortar and Grout Standards provides mortar mixing guidelines. Question 33. When mixing grout for filling concrete masonry unit cores, what consistency must the grout achieve to flow properly? A. A high slump flowable consistency that fills cores completely and surrounds steel bars. B. A stiff consistency that holds its shape when placed on a trowel without slumping. C. A dry pack consistency similar to damp sand that can be tamped into position by hand. D. A medium consistency matching standard mortar so it can be troweled into the cores. The correct answer is A. A high slump flowable consistency that fills cores completely and surrounds steel bars. Grout for filling concrete masonry unit cores must have a high slump, flowable consistency, typically 200 to 250 mm slump, so it can flow around reinforcement bars and fill all voids within the cores. A stiff or dry pack consistency will bridge across the core openings and leave voids around the reinforcement. Standard mortar consistency is too stiff to flow into narrow cores. Mortar and Grout Standard specifies grout proportions and consistency requirements, and Masonry Construction Standard specifies placement procedures for grouted masonry. Question 34. Which mortar type is recommended by mortar and grout standards for below-grade masonry where high compressive strength is required? A. Type S mortar, which provides high compressive strength and good bond below grade. B. Type N mortar, the most common general-purpose mortar for above-grade veneer walls. C. Type O mortar, a low-strength mortar intended for interior non-load-bearing joints. D. Type K mortar, a historic restoration mortar with very low compressive strength. The correct answer is A. Type S mortar, which provides high compressive strength and good bond below grade. Mortar and Grout Standards recommends Type S mortar for below-grade masonry applications because it provides high compressive strength, minimum 12.5 MPa at 28 days, and good bond strength for resisting lateral earth pressure and moisture exposure. Type N is a medium-strength mortar suitable for above-grade exterior walls. Type O has low strength and is limited to interior non-load-bearing applications. Type K is used only in heritage restoration where matching original low-strength mortars is required. Question 35. What is the primary purpose of adding lime to a Portland cement and sand mortar mix for bricklaying? A. To increase the compressive strength of the mortar beyond what cement alone provides. B. To accelerate the initial set time so that bricks can be loaded sooner after laying. C. To improve workability, water retention, and flexibility of the mortar during laying. D. To reduce the overall material cost by replacing a portion of the Portland cement. The correct answer is C. To improve workability, water retention, and flexibility of the mortar during laying. Adding lime to a Portland cement and sand mortar mix improves workability, making it easier to spread and butter, water retention, preventing premature drying that weakens the bond, and flexibility, accommodating minor structural movement without cracking. Lime actually reduces compressive strength slightly compared to a pure cement mortar. It does not accelerate setting. While it partially replaces cement, cost reduction is not its primary purpose. Mortar and Grout Standard specifies lime proportions for each mortar type. Question 36. Under what condition is it acceptable to retemper mortar by adding water and remixing on a masonry job site? A. Mortar can be retempered at any time regardless of how long since initial mixing. B. Only when the mortar has been returned to the mixer from the scaffold for more use. C. Within 2.5 hours of initial mixing if it's stiffened from evaporation only. D. Only if the mortar temperature drops below 10 degrees Celsius during cold weather. The correct answer is C. Within 2.5 hours of initial mixing if it's stiffened from evaporation only. Mortar may be retempered by adding water and remixing within 2.5 hours of the initial mixing, provided the stiffening is due to evaporation and not the beginning of the cement hydration set. After 2.5 hours, the cement has begun to set and adding water will weaken the mortar's final strength and bond. Retempering is not acceptable at any time. Return from the scaffold alone does not determine acceptability. Temperature alone is not the determining factor. Mortar and Grout Standard specifies the 2.5-hour limit for retempering. Question 37. What is the maximum grout pour height in a single lift when using low-lift grouting in concrete masonry walls? A. A maximum of 1,500 mm per lift with consolidation by vibration or manual rotting. B. A maximum of 600 mm per lift when the grout is placed by pouring from a bucket. C. A maximum of 900 mm per lift unless a mechanical vibrator is used to consolidate. D. No height restriction provided the grout has sufficient slump to flow into the cores. The correct answer is A. A maximum of 1,500 mm per lift with consolidation by vibration or manual rotting. Masonry Construction Standard specifies a maximum pour height of 1,500 mm, 1.5 meters, per lift for low-lift grouting of concrete masonry. The grout must be consolidated by mechanical vibration or manual rotting to ensure it fills all voids around reinforcement and within the cores. Grout placed in lifts higher than 1,500 mm risks bridging and void formation. The 600 mm and 900 mm limits are not standard requirements. Unrestricted pour heights would result in incomplete core filling and structural weakness. Question 38. A bricklayer notices that grout poured into concrete masonry unit cores is not reaching the bottom of the wall. What is the most likely cause? A. Mortar fins protruding into the cores from the bed joints are blocking grout flow. B. The grout mix has too much water and is flowing past the reinforcement too quickly. C. The ambient air temperature is too high, causing the grout to set before descending. D. The reinforcement steel diameter is too small to provide a path for grout to follow. The correct answer is A. Mortar fins protruding into the cores from the bed joints are blocking grout flow. Mortar fins protruding into the cores from the bed joints are the most common cause of grout blockage in concrete masonry walls. When mortar is squeezed into the cores during block laying, it hardens into fins or bridges that obstruct the grout flow path. Excess water causes segregation, not faster flow. High temperatures may accelerate setting but would not completely block fresh grout. Steel diameter does not affect the grout flow path. Careful mortar placement that minimizes squeeze out into the cores prevents this issue. Question 39. What is the primary function of weep holes in a brick veneer cavity wall system? A. To provide ventilation openings that allow fresh air to circulate behind the veneer. B. To equalize air pressure between the cavity and exterior during high wind events. C. To accommodate thermal expansion of the brick veneer during seasonal changes. D. To allow moisture that collects on the flashing to drain to the exterior of the wall. The correct answer is D. To allow moisture that collects on the flashing to drain to the exterior of the wall. Weep holes allow moisture that has entered the cavity and collected on the flashing to drain to the exterior of the wall. Without weep holes, water accumulates on the flashing and can rise to a level that penetrates the backup wall. While weep holes do provide some ventilation, their primary function is moisture drainage. They are not designed for pressure equalization or thermal expansion. Masonry construction standards requires weep holes at all flashing locations at a maximum spacing of 800 mm. Question 40. What is the correct spacing for control joints in a non-load-bearing concrete masonry unit partition wall? A. Control joints should be spaced at intervals not exceeding 1.5 times the wall height. B. Control joints should be placed at a maximum of 3 meters on center in every wall. C. Control joints are only required at intersections with load-bearing structural walls. D. Control joints should be placed at every door and window opening along the wall. The correct answer is A. Control joints should be spaced at intervals not exceeding 1.5 times the wall height. For non-load-bearing concrete masonry partition walls, control joints should be spaced at intervals not exceeding approximately 1.5 times the wall height. For a typical 3-meter-high wall, this means control joints approximately every 4.5 meters. This ratio-based spacing accounts for the shrinkage characteristics of concrete masonry. Fixed 3-meter spacing does not consider wall height. Joints only at structural intersections or openings would leave large uncontrolled areas. Masonry design standards provides guidance on control joint spacing for masonry walls. Question 41. What is the minimum airspace required between the brick veneer and the backup wall in a standard cavity wall system? A. No minimum airspace is specified as long as the insulation fills the entire cavity. B. A minimum 50 mm airspace is required for all cavity walls regardless of wall height. C. A minimum 25 mm clear airspace must be maintained for drainage and ventilation. D. The airspace must equal the thickness of the insulation used in the wall assembly. The correct answer is C. A minimum 25 mm clear airspace must be maintained for drainage and ventilation. A minimum 25 mm clear airspace must be maintained between the back face of the brick veneer, or the insulation surface, and the veneer for moisture drainage and air circulation. This airspace allows water that penetrates the veneer to drain down to the flashing and out through weep holes. Filling the cavity entirely with insulation blocks this drainage path. The 50 mm dimension is not the standard minimum. The airspace is independent of insulation thickness. Masonry construction standard specifies the minimum 25 mm airspace requirement. Question 42. When installing expansion joints in a clay brick veneer wall, what material is used to fill the joint? A. The joint is filled with standard mortar and then tooled to match the adjacent joints. B. The joint is left completely open without any filler to allow maximum wall movement. C. A rigid plastic strip is inserted into the joint to maintain the gap width over time. D. A compressible foam backer rod is placed in the joint and sealed with flexible sealant. The correct answer is D. A compressible foam backer rod is placed in the joint and sealed with flexible sealant. Expansion joints in clay brick veneer walls are filled with a compressible foam backer rod sized to fit the joint width, then sealed with a flexible elastomeric sealant, typically polyurethane or silicone, that can accommodate the expected brick expansion. Mortar is rigid and would crack as the brick expands. An open joint allows water entry and is not weather-tight. Rigid plastic cannot compress or expand with the wall movement. Masonry Construction Standard specifies expansion joint construction details for clay brick masonry. Question 43. What is the correct procedure for maintaining the cavity clear of mortar droppings during brick veneer construction? A. Place a mortar catching device in the cavity and raise it as each course is completed. B. Allow mortar to fall into the cavity and remove all accumulated debris after topping out. C. Install a cavity drainage mat against the backup wall to prevent mortar accumulation. D. Use a low slump mortar that does not squeeze out of the bed joints during laying. The correct answer is A. Place a mortar catching device in the cavity and raise it as each course is completed. A mortar catching device, such as a board with a rope or a manufactured cavity drainage board, is placed in the cavity at the bottom of the working area and raised as each course is completed. This catches mortar droppings before they accumulate on the flashing and block weep holes. Leaving debris until topping out makes removal difficult and risks blocking drainage. Drainage mats do not prevent mortar bridges that block the air space. Low slump mortar alone does not prevent all droppings. Question 44. What is the purpose of installing a shelf angle at each floor level in a multi-story brick veneer wall? A. To provide additional wall tie attachment points at each floor for lateral bracing. B. To serve as a decorative element that creates a visual band at each story level. C. To increase the compressive strength of the veneer with at high-stress floor lines. D. To support the weight of the brick veneer above and allow vertical movement joints. The correct answer is D. To support the weight of the brick veneer above and allow vertical movement joints. Shelf angles are installed at each floor level in multi-story brick veneer construction to support the weight of the brick veneer above that point and to accommodate vertical differential movement between the structural frame and the brick width. A horizontal soft joint is provided below each shelf angle to allow for structural deflection and brick expansion. The shelf angles are not primarily for tie attachment, decoration, or compressive strength. Masonry design standards and masonry construction standards specify shelf angle requirements for multi-story masonry veneer. Question 45. When building a concrete masonry unit partition wall, what is the correct method for anchoring the wall to the structural ceiling? A. Fill the gap between the top course and the ceiling with rigid mortar for a tight fit. B. Use a compressible material at the top to allow deflection while maintaining support. C. Leave a 25 mm gap between the top course and the ceiling with no filler material. D. Bolt the top course directly to the ceiling slab with expansion anchors every 600 mm. The correct answer is B. Use a compressible material at the top to allow deflection while maintaining support. A compressible material such as a deflection track or foam strip is installed at the top of a non-load-bearing partition wall to allow for structural deflection of the floor or roof above without transmitting loads onto the partition. Rigid mortar would crack and transfer loads to the wall. An open gap provides no lateral support. Direct bolting would make the partition load-bearing and restrict deflection. Building codes require that non-load-bearing partitions accommodate structural deflection. Question 46. What is the primary structural difference between a load-bearing and a non-load-bearing masonry wall? A. Load-bearing walls always use clay brick while non-load-bearing walls use block only. B. Non-load-bearing walls do not require mortar joints between the masonry units. C. Load-bearing walls must be built with running bond while partition walls use stack bond. D. A load-bearing wall transfers roof and floor loads to the foundation below the wall. The correct answer is D. A load-bearing wall transfers roof and floor loads to the foundation below the wall. A load-bearing masonry wall transfers structural loads from the roof, floors, and other building elements downward through the wall to the foundation. This distinguishes it from a non-load-bearing partition wall which supports only its own weight and provides space separation. Both wall types can use clay brick or concrete block. Both require mortar joints. Bond pattern is determined by structural and aesthetic requirements, not solely by whether the wall is load-bearing. Masonry Design Standards governs the design of load-bearing masonry structures. Question 47. When building a reinforced concrete masonry unit wall, what is the correct placement of vertical reinforcement? A. Place rebar against the inside face shell of the block for maximum cover from weather. B. Center the vertical rebar in the cores at the spacing specified in the structural plans. C. Insert rebar into every core of the block wall regardless of the structural design. D. Lay rebar horizontally in the bed joints instead of vertically in the block cores. The correct answer is B. Center the vertical rebar in the cores at the spacing specified in the structural plans. Vertical reinforcement bars must be centered in the specified cores at the spacing indicated in the structural engineer's design drawings. Centering the rebar ensures adequate grout cover on all sides for proper bond and corrosion protection. Placing rebar against the face shell reduces cover and weakens the wall. Not every core requires reinforcement, it depends on the structural design. Horizontal reinforcement is separate from vertical and is placed in bond beams or horizontal joint reinforcement. Masonry Design Standard specifies reinforcement placement requirements for masonry. Question 48. What is the correct installation procedure for a precast concrete lintel over a window opening in a masonry wall? A. Set the lintel on the wall after the opening is framed and filled with temporary brick. B. Apply mortar only to the top of the lintel and not to the bearing ends on the wall. C. Install the lintel without any mortar bed and rely on the weight to hold it in place. D. Set the lintel on a full mortar bed with minimum bearing length on each side of opening. The correct answer is D. Set the lintel on a full mortar bed with minimum bearing length on each side of opening. A precast concrete lintel must be set on a full mortar bed with the minimum bearing length specified by the structural engineer on each side of the opening, typically a minimum of 200 mm. The mortar bed ensures even load distribution across the bearing surface. Setting after filling the opening reverses the construction sequence. Mortar is required at the bearing ends for proper load transfer. Dry setting without mortar creates point loads and instability. Masonry Design Standard specifies minimum bearing requirements for masonry lintels. Question 49. What is the minimum bearing length required for a steel lintel supporting a brick veneer wall over a window opening? A. A minimum of 50 mm bearing on each side to match 1/4 of a standard brick. B. No minimum bearing is required if the lintel is bolted to the structural frame above. C. A minimum of 300 mm bearing on each side to span the full width of the wall cavity. D. A minimum of 100 mm bearing on each side as specified in the structural design. The correct answer is D. A minimum of 100 mm bearing on each side as specified in the structural design. Steel lintels supporting brick veneer must have a minimum bearing length of 100 mm, approximately 4 inches, on each side of the opening. This provides adequate surface area to distribute the load of the masonry above into the supporting wall on each side. A 50 mm bearing is too short for adequate load distribution. Bolting to the frame does not eliminate the need for proper bearing. A 300 mm bearing exceeds the minimum requirement and may not be necessary. Masonry Design Standards and the steel lintel manufacturer specify minimum bearing requirements. Question 50. When constructing a concrete masonry unit pilaster to provide lateral support for a load-bearing wall, what is the correct building technique? A. Build the pilaster separately and then connect it to the wall with wall ties only. B. build the pilaster integrally with the wall by interlocking units at each course level. C. Stack the pilaster blocks on top of the wall after the main wall is fully completed. D. Cast the pilaster in place using concrete formwork without any masonry unit construction. The correct answer is B. Build the pilaster integrally with the wall by interlocking units at each course level. A pilaster must be built integrally with the wall by interlocking the pilaster units with the wall units at each course level. This interlocking pattern creates a monolithic connection that transfers lateral loads effectively between the wall and the pilaster. Building separately and connecting with ties does not provide adequate structural connection. Stacking after wall completion does not create the interlocking bond. Cast concrete pilasters are a different structural system. Masonry design standards requires pilasters to be bonded into the wall. Question 51. What is the primary requirement for preparing a substrate before laying brick pavers on a pedestrian patio? A. The substrate must be a minimum of 200 mm thick poured concrete with steel mesh. B. A compacted granular base with a screed layer of sand must provide a firm level surface. C. The substrate must be treated with a chemical bonding agent before any units are laid. D. A vapor barrier membrane must be placed directly under the pavers for moisture control. The correct answer is B. A compacted granular base with a screed layer of sand must provide a firm level surface. For a pedestrian patio with interlocking brick pavers, the substrate requires a compacted granular base, typically 100 to 150 mm of crushed gravel compacted in lifts, topped with a screed layer of coarse bedding sand, approximately 25 mm, that provides a firm, level surface for the pavers. A poured concrete base is used for mortared installations, not typical interlocking pavers. Chemical bonding agents are not required for sandset pavers. A vapor barrier is not needed for exterior at-grade paver installations. Question 52. What is the correct method for establishing proper drainage slope on a horizontal masonry substrate for an exterior patio? A. Grade the granular base to slope a minimum of 2% away from the building structure. B. Build the substrate perfectly level and rely on the paver joints for water drainage. C. Slope the substrate with a random crown at the center that directs water in all directions. D. Install perimeter drains around the patio edges without sloping the substrate surface. The correct answer is A. Grade the granular base to slope a minimum of 2% away from the building structure. The granular base for an exterior patio must be graded to slope a minimum of 2%, approximately 20 mm per meter, away from the building structure to ensure positive drainage. A perfectly level substrate will pond water on the surface. A random crown creates uncontrolled drainage patterns. Perimeter drains alone without surface slope still allow water to sit on the patio. The 2% minimum slope is specified in building codes for adjacent grade surfaces. Question 53. What material is typically used for the bedding layer directly beneath interlocking brick pavers on a patio? A. Coarse, sharp-grained bedding sand screed to an even 25 mm thickness on the base. B. A thin layer of Portland cement spread dry on top of the compacted gravel base. C. A flexible polymer adhesive applied to the top of the compacted aggregate base. D. A pre-mixed concrete mortar spread to a uniform thickness of 50 mm across the base. The correct answer is A. Coarse, sharp-grained bedding sand screed to an even 25 mm thickness on the base. Coarse, sharp-grained bedding sand, typically conforming to industry aggregate standards, screed to an even thickness of approximately 25 mm on top of the compacted aggregate base is the standard bedding material for interlocking brick pavers. The angular sand grains lock together under compaction to support the pavers. Dry cement creates a rigid layer that cracks under movement. Polymer adhesive is used for thin-set applications on concrete, not aggregate bases. A 50 mm mortar bed is used for different installation methods. Question 54. What is the correct procedure for laying interlocking brick pavers in a herringbone pattern on a prepared sand bed? A. Begin at the center of the area and work outward in a circular pattern to each edge. B. Lay all pavers loosely across the entire area first and then compact them all at once. C. Set each paver in a thin mortar bed rather than directly on the screed sand layer. D. Start from the border edge, lay pavers at 45 or 90 degrees, and cut edge pavers last. The correct answer is D. Start from the border edge, lay pavers at 45 or 90 degrees, and cut edge pavers last. The correct procedure for a herringbone pattern is to start from a straight border edge or corner, lay the pavers at either 45 or 90 degrees to the border depending on the specified pattern, and cut the edge pavers to fit last using a masonry saw. Starting from the edge ensures alignment with the border. Center outward installation makes it difficult to maintain the pattern alignment at the edges. Loose placement without progressive alignment causes pattern drift. Sandset pavers do not require mortar bedding. Question 55. When laying clay brick treads on exterior masonry steps, what is the correct installation method? A. Dry set the treads on the concrete step without mortar and fill the joints with sand. B. Glue the brick treads to the step surface with construction adhesive applied in beads. C. Stack 2 layers of brick on each step to increase the tread height and weather resistance. D. Bed the brick treads in mortar on the concrete step with the treads sloped to drain. The correct answer is D. Bed the brick treads in mortar on the concrete step with the treads sloped to drain. Clay brick treads on exterior masonry steps must be bedded in mortar on the prepared concrete step substrate, with each tread sloped slightly forward, approximately 2%, to allow water to drain off the surface and prevent ice buildup. Dry set treads will shift and become a tripping hazard. Construction adhesive does not provide the structural bond needed for exterior step applications. Double stacking increases weight without improving weather performance and creates a non-standard riser height. Question 56. What joint filler material is swept into the joints of interlocking brick pavers after compaction is complete? A. Fine-grained joint sand or polymeric sand is swept into the joints and compacted. B. A pre-mixed mortar slurry is poured over the surface and worked into each joint. C. Standard type and mortar is troweled into each joint by hand after paver placement. D. No filler material is required as the tight paver fit prevents lateral movement. The correct answer is A. Fine-grained joint sand or polymeric sand is swept into the joints and compacted. After interlocking pavers are compacted with a plate compactor, fine-grained joint sand or polymeric sand is swept into the joints between the pavers. The sand fills the voids and, combined with the interlock shape of the pavers, creates a unified pavement surface that resists lateral movement and load transfer. Polymeric sand hardens when wetted, providing additional joint stability. Mortar slurry and hand troweled mortar are used for mortared installations, not interlocking sandset systems. Unfilled joints allow paver movement. Question 57. What is the primary advantage of using prefabricated masonry panels instead of building masonry walls on site? A. Prefabricated panels eliminate the need for mortar joints between the masonry units. B. Panels are always lighter than site-built masonry because they use hollow core brick. C. Prefabricated panels do not require any structural connections to the building frame. D. Panels are built in a controlled environment allowing consistent quality and speed. The correct answer is D. Panels are built in a controlled environment allowing consistent quality and speed. Prefabricated masonry panels are built in a controlled shop environment where temperature, humidity, and curing conditions are optimized. This produces consistently higher quality mortar joints and unit alignment compared to variable field conditions, and the work proceeds faster without weather delays. Prefab panels still use mortar joints between units. They are not necessarily lighter as they use the same masonry units. They require engineered connections to the building frame for structural support and load transfer. Question 58. When building a prefabricated masonry panel in a shop, what must be installed before the panel is moved to the job site? A. All exterior sealant and weatherproofing materials must be fully applied and cured. B. Lifting anchors and structural reinforcement must be embedded during the panel build. C. The final color mortar pointing must be completed and fully cured before any movement. D. All flashing and weep hole components must be permanently sealed before transport. The correct answer is B. Lifting anchors and structural reinforcement must be embedded during the panel build. Lifting anchors for crane attachment and structural reinforcement, rebar and/or welded wire, must be embedded during the panel construction process. These components cannot be added after the panel is built because they must be integrated into the mortar joints and grout cores during construction. Sealant and pointing can be completed after installation. Flashing details are often completed during final installation and connection to the building. Proper lifting anchor placement is critical for safe crane handling during transport and erection. Question 59. What is the correct procedure for lifting and placing a prefabricated masonry panel onto a building structure? A. Attach the crane slings to any convenient point on the panel and lift it into place. B. Connect the crane to the engineered lifting points and guide the panel into position. C. Tilt the panel upright from a flat position on the ground and slide it to the wall line. D. Roll the panel along the ground on pipe rollers to the wall location and tilt it upright. The correct answer is B. Connect the crane to the engineered lifting points and guide the panel into position. Prefabricated masonry panels must be connected to the crane using the engineered lifting points, cast-in lifting anchors, that were embedded during panel fabrication. These points are designed to distribute the panel weight evenly and prevent cracking during the lift. Workers then guide the panel into its final position on the building structure using tag lines. Attaching slings to arbitrary points risks cracking the panel. Tilting or rolling heavy masonry panels on the ground is unsafe and can damage the panel. Rigging standards governs rigging procedures. Question 60. What type of substrate is required for installing thin brick veneer units using an adhesive mortar system? A. Any smooth painted surface that has been wiped clean of dust before installation. B. A primed wood substrate with moisture barrier film applied over the sheathing layer. C. A clean, structurally sound substrate such as concrete, CMU, or cementitious board. D. A layer of fiberglass mesh over foam insulation board attached to the wall framing. The correct answer is C. A clean, structurally sound substrate such as concrete, CMU, or cementitious board. Thin brick veneer adhesive mortar systems require a clean, structurally sound substrate that can support the veneer weight and provide a good bond surface. Concrete masonry units, and cementitious backer board are suitable substrates. Painted surfaces do not provide reliable bond. Wood substrates require a scratch coat or cementitious board overlay. Foam insulation alone does not provide the structural capacity or bond surface needed. Manufacturer installation instructions specify approved substrate types. Question 61. What is the correct substrate preparation for installing manufactured stone veneer on a wood frame exterior wall? A. Install a weather-resistant barrier, metal lath, and a scratch coat of mortar first. B. Apply the stone veneer directly to the oriented strand board sheathing with adhesive. C. Paint the sheathing with a waterproof coating and apply the veneer units with mastic. D. Screw cementitious board to the studs and apply veneer without any additional layers. The correct answer is A. Install a weather-resistant barrier, metal lath, and a scratch coat of mortar first. The correct preparation for manufactured stone-on-wood framing requires installing a weather-resistant barrier, building paper or house wrap, over the sheathing, fastening galvanized or stainless steel metal lath to the framing, and then applying a scratch coat of mortar, typically 10 to 15 mm thick, that provides the bonding surface for the stone veneer. Direct application to OSB provides no bond surface. Paint and mastic are not approved for structural stone veneer. Cementitious board alone may still require lath and scratch coat depending on manufacturer specifications. Question 62. What is the purpose of scoring or scratching the surface of a mortar scratch coat before installing surface-bonded masonry units? A. To create a decorative texture that is visible through the joints of the veneer units. B. To reduce the total thickness of the scratch coat by removing excess mortar material. C. To create a rough surface with grooves that improves the mechanical bond of the veneer. D. To accelerate the curing of the scratch coat by increasing the surface area exposed. The correct answer is C. To create a rough surface with grooves that improves the mechanical bond of the veneer. Scoring or scratching the surface of the mortar scratch coat creates a rough, grooved surface that improves the mechanical bond between the scratch coat and the setting mortar used to adhere the surface-bonded masonry units. The grooves provide additional surface area and keying action for the setting bed. The scratches are not visible after the veneer is installed. Scratching does not reduce thickness in a meaningful way. Increased surface area exposure does not significantly affect cure time compared to mixed design and environmental conditions. Question 63. What is the correct method for applying thin brick veneer units to a prepared scratch coat on an exterior wall? A. Press each unit lightly against the dry scratch coat and hold for 10 seconds until set. B. Apply adhesive only to the scratch coat surface, then slide each unit into final position. C. Soak each thin brick in water for 30 minutes before setting to prevent mortar drying. D. Apply mortar to both the scratch coat and the back of the unit, then press firmly in place. The correct answer is D. Apply mortar to both the scratch coat and the back of the unit, then press firmly in place. The correct application method for thin brick veneer involves applying a layer of setting mortar to both the prepared scratch coat surface and the back of each thin brick unit, back buttering. The unit is then pressed firmly into position with a slight twisting motion to ensure full contact and eliminate air pockets. Pressing against a dry surface provides no bond. Adhesive on the wall only may leave voids behind the unit. Soaking thin brick is not standard practice as they are designed for adhesive application. The dual application ensures maximum bond strength. Question 64. When installing manufactured stone veneer on an exterior wall, what is the correct starting point for the installation? A. Begin at the top of the wall and work downward to prevent mortar drips on finished units. B. Start at the center of the wall and work outward toward both edges simultaneously. C. Begin at any convenient point on the wall as the adhesive holds units at any position. D. Begin at the bottom of the wall and work upward so each course is supported by below. The correct answer is D. Begin at the bottom of the wall and work upward so each course is supported by below. Manufactured stone veneer installation begins at the bottom of the wall and works upward so that each subsequent row of stone is mechanically supported by the row below it during the mortar curing period. Corner pieces are typically installed first, then flat pieces fill between them. Starting at the top risks stones sliding down before the mortar sets. Starting at the center makes it difficult to coordinate the pattern. While adhesive provides some hold, gravity support from below is essential for proper installation until the mortar reaches initial set strength. Question 65. What is the primary advantage of using thin brick veneer instead of full-depth brick for an interior accent wall? A. Thin brick veneer is available in more color options than standard full-depth brick. B. Thin brick veneer eliminates the need for any substrate preparation before application. C. Thin brick veneer reduces the wall weight and does not require a structural foundation. D. Thin brick veneer provides better thermal insulation value than full-depth masonry walls. The correct answer is C. Thin brick veneer reduces the wall weight and does not require a structural foundation. The primary advantage of thin brick veneer, typically 12 to 25 mm thick, for an interior accent wall is that it significantly reduces the wall weight compared to full-depth brick, 90 mm, eliminating the need for a structural foundation or floor reinforcement to support the masonry load. Standard full-depth brick on an interior wall would require an engineered foundation. Color options are similar between thin and full-depth brick. Substrate preparation is still required. The thin profile has minimal insulation value compared to full masonry. Question 66. Which natural stone type is classified as a metamorphic rock and is commonly used for interior flooring and countertops? A. Sandstone, which is formed by the cementation of sand grains in sedimentary layers. B. Granite, which is formed by the slow cooling of molten magma deep below the surface. C. Marble, which is formed by the recrystallization of limestone under heat and pressure. D. Limestone, which is formed from compressed marine sediment and fossil shell deposits. The correct answer is C. Marble, which is formed by the recrystallization of limestone under heat and pressure. Marble is a metamorphic rock formed when limestone is subjected to intense heat and pressure deep within the earth, causing the calcite crystals to recrystallize into an interlocking pattern. Marble is prized for interior flooring, countertops, and decorative masonry due to its distinctive veining and polish. Sandstone and limestone are sedimentary rocks. Granite is an igneous rock. Understanding stone classification helps bricklayers select appropriate materials and installation methods. Question 67. What is the correct method for cutting a natural stone slab to a specified dimension using a diamond blade saw? A. Score the stone surface with a chisel along the line and snap it over a straight edge. B. Mark the cut line, secure the stone, use water cooling, and cut at a steady feed rate. C. Use a dry abrasive wheel at maximum speed to make the cut without water to avoid mess. D. Cut the stone freehand without clamping and adjust the angle during the cutting pass. The correct answer is B. Mark the cut line, secure the stone, use water cooling, and cut at a steady feed rate. Cutting natural stone requires marking the cut line accurately, securing the stone firmly to prevent movement, using a diamond blade saw with continuous water cooling to reduce dust and prevent blade overheating, and feeding the stone through at a steady rate appropriate for the stone type. Scoring and snapping produces rough irregular edges unsuitable for precision work. Dry cutting generates dangerous silica dust and overheats the blade. Freehand cutting without clamping is unsafe and inaccurate. Question 68. When preparing irregular natural stone for a rubble wall, what tool is used to remove projections and shape the bearing surfaces? A. A standard masonry trowel is used to scrape and flatten the bearing surfaces of stone. B. A mason's hammer and pitching tool are used to trim projections and shape bed faces. C. A belt sander with coarse grit is used to smooth all bearing surfaces before laying. D. A pneumatic jackhammer is used to split large stones into smaller workable pieces. The correct answer is B. A mason's hammer and pitching tool are used to trim projections and shape bed faces. A mason's hammer, or stone hammer, combined with a pitching tool or chisel is used to trim projections, remove high spots, and shape the bearing surfaces of irregular natural stone for rubble wall construction. The pitching tool allows controlled removal of stone material along natural fracture planes. A masonry trowel is for mortar, not stone shaping. Belt sanding is impractical for rough stone preparation. A jackhammer is too aggressive for precision shaping and would shatter the stone. Question 69. What is the correct procedure for laying natural stone in a random rubble wall pattern? A. Stack stones vertically in columns with mortar only in the horizontal bed joints. B. Sort all stones by size and color before laying and use them in a strict sequence. C. Select stones for fit, place larger units at the base, and stagger vertical joints. D. Set each stone on a dry bed without mortar and fill the joints after completing a row. The correct answer is C. Select stones for fit, place larger units at the base, and stagger vertical joints. Random rubble stone walls are built by selecting stones for fit, placing the largest and heaviest units at the base of the wall for stability, and staggering the vertical joints to create an interlocking pattern. Each stone is bedded in mortar with all voids filled. Vertical stacking creates weak columns that can collapse. Strict size sequencing defeats the random rubble aesthetic. Dry setting without mortar does not provide structural bond. Proper rubble wall construction requires skill in selecting stones that interlock and distribute loads. Question 70. What type of mortar is generally recommended for laying natural stone walls to avoid staining porous stone surfaces? A. Standard gray Portland cement mortar with a high cement-to-sand ratio for strength. B. A fast-setting polymer mortar designed for rapid construction and quick curing times. C. White Portland cement mortar with lime, which reduces the risk of staining light stone. D. A colored mortar mixed with iron oxide pigment to match the natural stone color. The correct answer is C. White Portland cement mortar with lime, which reduces the risk of staining light stone. White Portland cement mortar with lime is recommended for natural stone walls, particularly when using light-colored or porous stones such as limestone and marble. Standard gray Portland cement contains iron compounds that can leach through porous stone and cause permanent brown or gray staining. White cement eliminates this risk. Fast-setting polymers may not be compatible with all stone types. Iron oxide pigments can also cause staining if they migrate through porous stone surfaces. Question 71. When laying coursed ashlar stone on an exterior wall, what must be checked at each course to ensure proper alignment? A. The color consistency of each stone compared to the adjacent stones in the course. B. Level across the top of each course and plumb on the face using a spirit level. C. The total weight of each course to verify it does not exceed the structural capacity. D. The mineral grain direction of each stone to confirm it matches the specified pattern. The correct answer is B. Level across the top of each course and plumb on the face using a spirit level. Coursed ashlar stone walls require checking level across the top of each course and plumb on the face of the wall using a spirit level at every course. Ashlar stone is cut to uniform heights and laid in regular courses, so maintaining level and plumb is essential for the precise, formal appearance of this wall type. Color consistency is an aesthetic concern but not the primary alignment check. Weight verification is a design concern addressed before construction. Grain direction is relevant for some applications but is not the primary course-by-course check. Question 72. What is the primary purpose of damp curing a newly constructed natural stone wall? A. To darken the color of the stone permanently for a more uniform visual appearance. Damp curing a newly constructed natural stone wall ensures that the mortar joints retain sufficient moisture to allow the Portland cement to hydrate fully and develop maximum bond strength between the mortar and the stone surfaces. Without adequate moisture during curing, the mortar dries prematurely, resulting in weak joints with poor adhesion. Damp curing does not permanently change stone color. It is not a leak test or a cleaning method. Natural stone walls are particularly susceptible to rapid moisture loss through porous stone. Question 73. What is the correct procedure for preparing a concrete substrate to receive mechanically fastened natural stone cladding? D. Apply a layer of spray foam insulation to the concrete before installing the anchors. Preparing a concrete substrate for mechanically fastened stone cladding requires verifying that the concrete has adequate compressive strength for the specified anchors, surveying and marking the anchor locations according to the engineered layout drawings, and drilling holes to the diameter, depth, and spacing specified by the structural engineer. Painting is not a substrate preparation for mechanical fastening. Roughening is for adhesive bonded systems. Spray foam does not provide structural capacity for mechanical anchors. Question 74. What is the minimum concrete compressive strength typically required for mechanically fastened stone cladding anchors? A. Any concrete strength is acceptable as long as the anchors are installed deep enough. B. A minimum of 10 MPa which matches the minimum strength for residential foundations. Mechanically fastened stone cladding anchors typically require a minimum concrete compressive strength of 20 MPa, approximately 3000 psi, as specified by both the anchor manufacturer and the structural engineer. This minimum ensures the concrete can resist the pull-out and shear loads imposed by the stone cladding and wind loading. Lower strength concrete may not develop adequate anchor capacity. Depth alone does not compensate for weak concrete. Mechanical anchors rely on concrete bearing strength, not friction alone. Question 75. When preparing natural stone panels for mechanical fastening, what is the correct method for cutting anchor slots in the panel edges? Anchor slots in natural stone cladding panels must be cut using a slot cutting router or a diamond blade saw at the specific locations, dimensions, and depth specified in the engineering drawings. Precision is critical because undercut or oversized slots reduce the stone's edge strength and compromise anchor performance. Freehand cutting lacks the precision needed. Face-drilled holes weaken the panel differently than edge slots. Hand chiseling risks cracking the stone along natural fracture planes. Manufacturer specifications govern slot dimensions. Question 76. What precaution must be taken when drilling anchor holes in thin natural stone panels to prevent panel cracking? C. Drill from the face side only and stop when the bit reaches 3/4 depth. D. Clamp the panel between two plywood sheets and drill through all layers at full depth. Drilling anchor holes in thin natural stone panels requires using a diamond core bit with continuous water cooling to prevent heat buildup, which can cause thermal cracking in stone. A controlled drilling speed reduces vibration stress on the panel. Standard masonry bits at maximum speed generate excessive heat and vibration. Stopping at 3/4 depth may not meet the anchor depth specification. Sandwiching between plywood does not prevent thermal cracking and makes it difficult to monitor hole depth and alignment. Question 77. What type of anchor is most commonly used to support natural stone cladding panels on a building exterior? D. Adhesive-only anchors with no mechanical fastener component for a clean installation. Stainless steel kerf anchors, which engage slots cut into the top and bottom edges of the stone panel, or pin anchors, which insert into drilled holes in the panel edges, are the most common mechanical fastening systems for exterior natural stone cladding. Stainless steel resists corrosion in exterior exposure. Wood screws are not suitable for stone or concrete. Toggle bolts do not provide the precise adjustment needed. Adhesive-only systems are not accepted as primary structural connections for exterior stone cladding on tall buildings. Question 78. What is the correct procedure for installing a mechanically fastened natural stone cladding panel on a building facade? A. Apply construction adhesive to the back of the panel and press it against the substrate. B. Drill through the face of the stone panel into the substrate and insert expansion bolts. The correct installation procedure involves setting the support anchors into the prepared substrate holes, lowering the stone panel onto the kerf or pin anchors so the panel slots engage the anchors, and then shimming the panel to achieve the specified alignment, plumb, and joint width before locking the anchors in their final position. Adhesive alone does not provide a mechanically fastened connection. Face drilling damages the visible surface. Top-down stacking loads the upper anchors with cumulative weight that exceeds their capacity. Question 79. What is the correct procedure for constructing a foundation to support a masonry chimney in a residential building? A. Pour a reinforced concrete footing size to support the full weight of the chimney. B. Set the chimney base directly on the basement floor slab without a separate footing. C. Build the chimney off a wooden platform supported by the floor joist system above. D. Stack concrete blocks on undisturbed soil without any concrete footing underneath. The correct answer is A. Pour a reinforced concrete footing size to support the full weight of the chimney. A masonry chimney requires a reinforced concrete footing designed to support the full weight of the chimney, including the firebox, flue liner, and all masonry above the roofline. The footing must be sized based on the soil bearing capacity and the chimney load, typically a minimum of 300 mm thick. Setting on a basement slab risks slab cracking. Wood platforms cannot support masonry weight. Blocks on soil without a footing will settle unevenly. The Solid Fuel Appliance Installation Code and Building Code specify chimney foundation requirements. Question 80. According to the Solid Fuel Appliance Installation Code, what is the minimum clearance required between a masonry chimney and combustible building materials? A. No clearance is required if the chimney is built with fire-rated masonry units. B. A minimum of 50 mm clearance must be maintained between the chimney and combustibles. C. A minimum of 25 mm clearance with fire-rated insulation filling the entire gap space. D. A minimum of 100 mm clearance is required for all chimney installations in Canada. The correct answer is B. A minimum of 50 mm clearance must be maintained between the chimney and combustibles. The Solid Fuel Appliance Installation Code requires a minimum of 50 mm, 2 inches, clearance between a masonry chimney and any combustible building materials such as wood framing, insulation, and sheathing. This air gap prevents heat transfer from the chimney to combustible materials. No clearance would create a fire hazard. A 25 mm gap is insufficient for residential chimneys. While some jurisdictions may require more, 50 mm is the Solid Fuel Appliance Installation Code minimum standard. Question 81. What is the correct method for building a masonry chimney through a combustible roof structure? A. Pack fiberglass insulation between the chimney masonry and the roof framing members. B. Build the chimney tight against the roof framing and seal the gap with fire caulking. C. Frame a clearance opening around the chimney and install a metal fire stop at each level. D. Wrap the chimney in sheet metal before passing through the roof deck opening area. The correct answer is C. Frame a clearance opening around the chimney and install a metal fire stop at each level. When a masonry chimney passes through a combustible roof structure, a clearance opening must be framed around the chimney maintaining the required 50 mm minimum clearance to combustibles, and a non-combustible metal fire stop must be installed at each floor and ceiling level to prevent fire spread through the concealed space. Fiberglass insulation is combustible and provides inadequate fire protection. Building tight against framing violates clearance requirements. Sheet metal wrapping alone does not address the clearance gap. The Solid Fuel Appliance Installation Code and Building Codes specify fire stop requirements. Question 82. What is the minimum height a masonry chimney must extend above the highest point where it passes through the roof? A. The chimney must be flush with the roof surface and capped with a rain cap only. The Solid Fuel Appliance Installation Code requires that a masonry chimney extend a minimum of 900 mm, approximately 3 feet, above the highest point where it passes through the roof. Additionally, the chimney top must be at least 600 mm higher than any part of the building or adjacent structure within a 3-meter horizontal distance. These height requirements ensure adequate draft and prevent downdrafts from nearby roof surfaces or structures. A flush chimney, 600 mm height, or 300 mm above the ridge would not meet the minimum 900 mm requirement at the penetration point. Question 83. What is the primary purpose of installing a clay tile or stainless steel flue liner inside a masonry chimney? C. To reduce the total weight of the chimney by replacing solid masonry with a thin liner. D. To provide structural reinforcement that prevents the chimney from leaning or settling. A flue liner protects the chimney masonry from the damaging effects of high temperatures, corrosive combustion gases, including acidic condensate, and moisture penetration. Without a liner, heat and chemicals would degrade the mortar joints, potentially allowing toxic gases to leak into the building and creating a fire hazard. The liner also provides a smooth, correctly sized passage for efficient draft. It is not primarily decorative, does not reduce chimney weight significantly, and does not serve as structural reinforcement. The Solid Fuel Appliance Installation Code requires flue liners in masonry chimneys. Question 84. What is the correct method for installing clay flue liner tiles inside a masonry chimney during construction? A. Lower all flue tiles into the chimney from the top after the masonry walls are complete. D. Stack the tiles inside the chimney without mortar and fill the gap with loose insulation. Clay flue liner tiles are installed as the chimney is being built, setting each tile on a bed of refractory mortar on top of the previous tile and then building the masonry chimney walls around it course by course. This method ensures proper mortar joints between liner sections and correct alignment. Lowering tiles from the top after construction makes it impossible to mortar the joints. Sliding from the bottom is physically impractical for tall chimneys. Dry stacking without mortar allows gas leaks at the joints. The solid fuel appliance installation code requires mortared flue liner joints. Question 85. What is the correct procedure for constructing the foundation for a masonry fireplace hearth and firebox? A. Build the hearth directly on the wood subfloor with a layer of cement board underneath. D. Suspend the hearth from steel brackets attached to the wall framing above the floor. The fireplace foundation is constructed by extending the chimney footing outward to support the full weight of the hearth, firebox, backup masonry, and veneer facing. This integrated footing ensures that all masonry loads are transferred directly to the ground through a properly designed foundation. Building on wood subfloor would overload the floor structure. A pad on finished floor provides no structural capacity. Steel brackets attached to wood framing cannot support masonry weight. The solid fuel appliance installation code requires a non-combustible foundation for masonry fireplaces. Question 86. According to the Rumford fireplace design principles, what is the recommended ratio of firebox depth to firebox opening width? The Rumford fireplace design specifies that the firebox depth should be approximately 1/3 of the opening width. This shallow firebox design with angled side walls reflects more radiant heat into the room, creating a more efficient fireplace. A firebox as deep as it is wide would absorb and waste heat in the masonry rather than radiating it. Twice the width would make the firebox excessively deep. Firebox proportions are not arbitrary, they directly affect draft, smoke control, and heat output. Count Rumford's proportions have been validated by centuries of use. Question 87. What type of brick must be used to line the interior of a masonry firebox to withstand direct flame exposure? A. Fire brick rated for high temperature exposure laid with refractory mortar joints. B. Standard clay face brick rated for exterior exposure in freeze-thaw climates. C. Lightweight concrete masonry units with a smooth face finish for easy cleaning. D. Reclaimed antique brick for an authentic heritage appearance in the firebox area. The correct answer is A. Fire brick rated for high temperature exposure laid with refractory mortar joints. The interior of a masonry firebox must be lined with fire brick, also called refractory brick, that is specifically rated for direct flame exposure and high temperatures, exceeding 1000 degrees Celsius. Fire brick is laid with thin joints of refractory mortar that can also withstand extreme heat. Standard clay brick would crack and spall from thermal shock. Concrete block is not rated for direct flame. Reclaimed brick may have unknown thermal properties and could fail dangerously. The solid fuel appliance installation code requires fire brick lining in masonry fireboxes. Question 88. What is the correct procedure for installing a throat damper in a masonry fireplace? A. Bolt the damper to the face of the fireplace opening above the decorative mantle. A throat damper is installed at the throat of the fireplace, which is the narrow opening between the top of the firebox and the entrance to the smoke chamber above. The damper frame is set in mortar on the masonry walls at the throat level, positioned so the damper plate can open fully to allow smoke passage and close to seal the flue when the fireplace is not in use. It is not mounted on the face of the fireplace, inside the flue liner, or in the firebox side walls. The solid fuel appliance installation code specifies damper location and operation requirements. Question 89. What is the correct construction method for building a smoke chamber above a masonry fireplace damper? A. Install a prefabricated metal box between the damper and the first flue liner tile. B. Leave the smoke chamber as a hollow rectangular space without any internal shaping. The smoke chamber is constructed by corbelling, stepping inward, the masonry walls gradually at each course above the damper, transitioning from the wider firebox opening to the smaller flue liner cross-section. The interior surface should be parged smooth with refractory mortar to create a smooth funnel shape that directs smoke and gases efficiently into the flue. A metal box does not provide the thermal mass or smooth transition needed. An unshaped hollow space creates turbulence. Rubble fill blocks the passage. The solid fuel appliance installation code specifies smoke chamber construction requirements. Question 90. A homeowner wants to install a wood stove insert into an existing masonry fireplace. The bricklayer discovers that the existing flue liner is cracked. What must be done before the insert is installed? A. Install the insert immediately as the metal insert body protects against flue defects. B. Apply a coat of refractory cement over the cracked liner tiles to seal the damage. A cracked flue liner must be addressed before installing a wood stove insert because cracks allow combustion gases, including carbon monoxide, to leak into the building structure and create fire hazards. The chimney must be relined with a new stainless steel flexible liner size to match the insert's flue collar requirements. Installing without addressing the crack exposes occupants to toxic gas leaks. Cement coating over cracks is not a permanent structural repair. Disconnecting the insert from the chimney would allow smoke to enter the living space. The solid fuel appliance installation code requires a continuous, intact flue liner for all solid fuel installations. Question 91. What is the primary characteristic that distinguishes refractory brick from standard clay masonry brick? A. Refractory brick is always larger in size than standard clay brick used in wall work. B. Refractory brick can withstand sustained temperatures exceeding 1000 degrees Celsius. C. Refractory brick is manufactured only in white or cream colors for easy identification. D. Refractory brick does not require mortar joints and is always installed using dry stack. The correct answer is B. Refractory brick can withstand sustained temperatures exceeding 1000 degrees Celsius. Refractory brick is specifically manufactured to withstand sustained temperatures exceeding 1000 degrees Celsius without structural degradation, spalling, or chemical breakdown. Standard clay brick is rated for much lower temperatures and would fail in high heat applications such as furnace linings, kilns, and industrial boilers. Refractory brick comes in various sizes, not always larger. It is available in multiple colors. It typically requires refractory mortar joints, though joint thickness is minimized. Question 92. What safety precautions must a bricklayer take when preparing to install refractories in an industrial furnace or kiln? D. A standard dust mask and leather gloves are the only additional items needed for work. Installing refractories in industrial settings requires heat-resistant clothing to protect against residual heat and hot surfaces, respiratory protection rated for refractory dust, which may contain silica, alumina, or chromium compounds, and lockout tag out of all energy sources, gas, steam, electrical, to prevent accidental activation of the furnace or kiln during work. Standard construction personal protective equipment alone is insufficient for the unique hazards of refractory environments. Provincial occupational health and safety regulations require specific hazard controls for confined space and industrial refractory work. Question 93. Why must refractory mortar be used instead of standard Portland cement mortar when installing firebrick? A. Refractory mortar is less expensive than standard mortar and reduces project costs. B. Standard mortar provides a stronger initial bond than refractory mortar at room temp. Standard Portland cement mortar breaks down and loses all bonding strength at temperatures above approximately 300 degrees Celsius. The calcium silicate compounds in Portland cement dehydrate and decompose, causing the mortar to crumble and the firebrick lining to fail. Refractory mortar is formulated with high alumina or silica-based binders that maintain strength and bond at the operating temperatures of furnaces, kilns, and fireboxes. Refractory mortar is typically more expensive than standard mortar, and its setting characteristics vary by type. Question 94. What is the correct method for mixing refractory mortar for a firebrick installation in an industrial application? Refractory mortar must be mixed in small batches following the manufacturer's specific directions, using clean water at the exact ratio specified. The working time of refractory mortar varies by type and can be quite short. Small batches prevent waste from material that sets before use. Adding extra water weakens the refractory properties and reduces the temperature rating. Standard mortar proportions do not apply. Pre-mixing is not recommended as many refractory mortars begin to set once water is added and have limited pot life. Question 95. What is the correct procedure for removing deteriorated refractory brick from an industrial furnace lining? A. Use a standard pneumatic demolition hammer at full power to remove all brick quickly. D. Remove the entire lining regardless of condition and replace it all with new material. Deteriorated refractory brick must be removed carefully using hand tools, chisels, hammers, and pry bars, to avoid damaging adjacent sound brick that can remain in service. Selective removal preserves the structural integrity of the remaining lining and reduces material costs and downtime. A pneumatic demolition hammer at full power damages surrounding good brick. Water on hot linings causes dangerous steam explosions and further thermal damage. Replacing the entire lining when only sections are damaged is wasteful and unnecessary. Question 96. What is the correct joint thickness for refractory mortar when laying firebrick in a furnace lining? A. A standard 10 mm joint thickness matching regular masonry construction practice. B. A thick 25 mm joint to provide extra insulation between the firebrick units and the wall. C. The thinnest joint possible, typically 1 to 3 mm, to maximize heat resistance of lining. D. No mortar joint is used as firebrick is always dry stacked in industrial installations. The correct answer is C. The thinnest joint possible, typically 1 to 3 mm, to maximize heat resistance of lining. Refractory mortar joints should be the thinnest possible, typically 1 to 3 mm, sometimes described as a dip joint or wipe joint. Thin joints minimize the amount of mortar in the lining because mortar is generally weaker than the firebrick at high temperatures and is the first point of failure. A 10 mm joint exposes too much mortar area to heat. A 25 mm joint would fail rapidly. While some applications use dry stacking, most industrial furnace linings require thin mortar joints for gas-tight construction. Question 97. What must be done after installing a new refractory lining before the furnace is brought up to full operating temperature? After installing a new refractory lining, the furnace temperature must be increased gradually over a controlled drying out schedule, typically over several days, to allow moisture in the mortar and refractory materials to evaporate slowly. Rapid heating causes steam pressure to build up inside the lining, which can cause explosive spalling and structural failure of the new brick. Immediate full temperature firing causes steam spalling. Air drying alone does not remove all moisture. Sealant coatings are not typically applied before the dry-out procedure. Question 98. In what type of industrial application are corrosion-resistant masonry materials most commonly required? Corrosion-resistant masonry materials, acid-resistant brick and chemical-resistant mortar, are most commonly required in chemical processing plants, acid storage tanks, secondary containment areas, and industrial waste treatment facilities where masonry is exposed to aggressive acids, alkalis, or chemical solutions that would rapidly destroy standard masonry. Residential fireplaces use refractory, not corrosion-resistant materials. Normal rainwater and foot traffic do not require chemical resistance. These specialized materials are significantly more costly than standard masonry. Question 99. What type of mortar is used to bond acid-resistant brick in a chemical containment structure? A. Standard type S Portland cement mortar with extra lime added for improved flexibility. B. A chemical-resistant epoxy, furan, or potassium silicate mortar matched to the exposure. C. A polymer-modified thinset mortar designed for ceramic tile installation on floors. D. Standard refractory mortar used for high-temperature furnace and kiln lining work. The correct answer is B. A chemical-resistant epoxy, furan, or potassium silicate mortar matched to the exposure. Acid-resistant brick in chemical containment structures requires chemical-resistant mortar specifically formulated to resist the chemicals present in the application. Common types include epoxy mortar, furan resin mortar, and potassium silicate mortar, each selected based on the specific chemical exposure, acid type, concentration, and temperature. Portland cement mortar dissolves in acid. Tile thinset lacks chemical resistance. Refractory mortar is designed for heat, not chemical resistance. The mortar type must be matched to the specific chemicals involved. Question 100. What precaution must be taken before removing existing corrosion-resistant masonry from a chemical storage containment area? A. Remove the masonry with standard demolition tools without any special preparation. D. Wait for the chemical residues to fully evaporate naturally before beginning removal. Before removing corrosion-resistant masonry from a chemical containment area, the bricklayer must ensure the area is tested for hazardous chemical residues and decontaminated according to the facility's safety procedures. Residual chemicals absorbed into the brick and mortar can pose serious health hazards including chemical burns, toxic fume inhalation, and skin absorption. Standard demolition without testing exposes workers to unknown hazards. Water flooding may spread contamination. Chemical residues in porous masonry do not simply evaporate. Provincial occupational health and safety hazardous materials regulations apply. Question 101. What is the primary difference between acid-resistant brick and standard clay face brick in terms of material properties? A. Acid-resistant brick is lighter in weight due to its higher porosity and void content. B. Acid-resistant brick is available only in red color while standard brick comes in many. C. Acid-resistant brick is softer than standard brick to allow easier cutting on the job site. D. Acid-resistant brick has very low porosity and high chemical resistance from dense firing. The correct answer is D. Acid-resistant brick has very low porosity and high chemical resistance from dense firing. Acid-resistant brick is fired at extremely high temperatures, above 1,200 degrees Celsius, producing a very dense, low-porosity unit with high chemical resistance. The dense structure prevents acids and chemicals from penetrating the brick surface. Standard clay face brick is fired at lower temperatures and has higher porosity. Acid-resistant brick is actually heavier than standard brick due to its density, not lighter. It comes in various colors. Its high density makes it harder to cut, not softer. Acid-resistant brick standard specifies acid-resistant brick requirements. Question 102. What is the primary reason for carefully disassembling masonry units during a heritage restoration project? A. To reduce the cost of waste disposal by stacking units neatly for efficient removal. B. To speed up the demolition process compared to using mechanical demolition equipment. C. To preserve the original masonry units for reuse in the restored wall wherever possible. D. To create an opening large enough for modern mechanical equipment to access the site. The correct answer is C. To preserve the original masonry units for reuse in the restored wall wherever possible. In heritage restoration, masonry units are carefully disassembled to preserve the original brick or stone for reuse in the restored wall. Heritage building standards typically require that original materials be retained and reused wherever possible to maintain the building's historical character and material authenticity. Careful removal also prevents damage to adjacent sound masonry. Cost reduction, speed, and equipment access are not the primary drivers. Heritage conservation guidelines from Parks Canada and provincial heritage authorities govern restoration practices. Question 103. What is the correct technique for removing individual brick units from a heritage masonry wall without damaging them? The correct technique involves cutting the mortar joints around each brick using an angle grinder or reciprocating saw with a diamond blade, then carefully prying the unit free using a flat pry bar or chisel. This method minimizes damage to both the unit being removed and the adjacent masonry. Heavy hammer strikes crack the brick. Cutting through the brick destroys it. Chemical dissolvers are slow, may damage the brick, and are not commonly used for individual unit removal. Remaining mortar is cleaned from salvaged units for reuse. Question 104. After removing salvageable brick from a heritage wall, what must be done to prepare the units for reinstallation? D. Grind all surfaces smooth with a masonry wheel to remove any remaining mortar traces. Salvaged brick units must have all old mortar cleaned from their surfaces using hand tools or careful mechanical cleaning, then be inspected for cracks, spalling, or damage that would prevent reuse, and sorted by size and color for matching during reinstallation. Sealant coating is not applied before reinstallation as it would prevent mortar bond. Prolonged acid soaking can damage the brick surface. Grinding removes the original fired surface and alters the unit dimensions and appearance. Question 105. Why is it important to document the existing conditions of a masonry wall before beginning a restoration project? A. Documentation is only required if the building owner requests a written report. B. A detailed record provides a baseline for matching materials and replicating patterns. C. Documentation is used solely for insurance claim purposes after the work is completed. D. Recording conditions is optional on heritage projects and is typically skipped for cost. The correct answer is B. A detailed record provides a baseline for matching materials and replicating patterns. Documenting existing conditions provides a detailed baseline record of the mortar color and composition, bond pattern, brick sizes, coursing heights, joint profiles, and deterioration patterns. This information is essential for matching replacement materials and replicating the original construction during restoration. Documentation is required by heritage conservation standards regardless of owner preference. It serves multiple purposes beyond insurance. It is not optional on heritage projects. Parks Canada standards and guidelines for the conservation of historic places require thorough documentation. Question 106. What is the correct method for documenting the existing condition of a heritage masonry wall before restoration begins? A. Take a single photograph of the overall wall from a distance to record its appearance. B. Rely on the architect's original construction drawings from the building permit files. Proper documentation requires detailed photographs of all wall areas, close-up and overview, mapping of deterioration patterns, cracking, spalling, efflorescence, staining, and collecting mortar and brick samples for laboratory analysis to determine composition and match replacement materials. A single distant photograph lacks detail. Original drawings may not reflect modifications or current conditions. Text descriptions without photos are insufficient for accurate material matching and pattern replication during restoration. Question 107. What is the correct method for protecting adjacent completed masonry work during a restoration project? A. No protection is needed if the adjacent masonry is built with the same type of brick. B. Apply a permanent waterproof sealant to all adjacent masonry surfaces before starting. C. Remove all adjacent completed masonry and rebuild it after the restoration is finished. D. Cover adjacent surfaces with protective sheeting and install temporary barriers. The correct answer is D. Cover adjacent surfaces with protective sheeting and install temporary barriers. Adjacent completed masonry must be covered with protective sheeting, polyethylene, plywood, or protective board, and temporary barriers installed to prevent damage from mortar splatter, dust, tool impacts, and cleaning chemicals during the restoration work. All masonry requires protection regardless of matching materials. Permanent sealant may alter the appearance of heritage masonry. Removing adjacent sound masonry is destructive and unnecessary. Protection measures are removed after the restoration work is complete. Question 108. When reinstalling salvaged masonry units in a heritage restoration, what must be done to ensure visual and structural compatibility? D. Apply a uniform stain to all salvaged units to create a consistent new color finish. Reinstalling salvaged units requires matching them by color, size, and texture to replicate the original wall appearance, and using a mortar that closely replicates the original composition in terms of binder type, aggregate, color, and strength. Using modern high-strength mortar on historic soft brick can cause the brick to crack and spall because the mortar is harder than the units. Random placement creates a visually inconsistent result. Staining masks the original character. Heritage conservation standards require material compatibility. Question 109. Why is it important to use lime-based mortar instead of modern Portland cement mortar when restoring historic masonry walls? C. Lime mortar sets faster than Portland cement, reducing the overall project timeline. D. Lime mortar is available in more colors than Portland cement for easier shade matching. Lime-based mortar is softer and more flexible than Portland cement mortar, which is critical for historic masonry because the mortar must be softer than the brick. Soft mortar accommodates building movement and allows moisture to evaporate through the joints rather than forcing it through the brick face, which would cause spalling and frost damage. Hard Portland cement mortar traps moisture and transfers stress to the softer historic brick. Cost, set time, and color range are not the primary reasons for selecting lime mortar. Heritage conservation standards require compatible mortar. Question 110. What is the correct technique for removing a single deteriorated brick from an existing wall for individual unit replacement? D. Apply a chemical brick dissolver to the unit face and wait for it to soften completely. Removing a single deteriorated brick requires cutting the mortar joints on all four sides using an angle grinder with a diamond blade, then carefully chiseling out the damaged unit in pieces without disturbing the surrounding sound brick. The cavity is then cleaned to receive the replacement unit. Breaking the brick with force risks damaging adjacent units. Removing surrounding bricks is unnecessarily destructive. Chemical dissolvers are not practical for individual brick removal and may damage surrounding mortar and brick. Question 111. To what minimum depth should deteriorated mortar be removed from joints before repointing an existing masonry wall? A. Only the loose surface mortar needs to be scraped off to a depth of 5 mm maximum. B. The joints should be raked out to the full depth of the brick to replace all mortar. C. A depth of 10 mm is sufficient for all repointing applications regardless of joint size. D. A minimum of twice the joint width or 20 mm, whichever is greater, for adequate bond. The correct answer is D. A minimum of twice the joint width or 20 mm, whichever is greater, for adequate bond. Deteriorated mortar should be removed to a minimum depth of approximately twice the joint width, or at least 20 mm, whichever is greater. This depth provides adequate surface area for the new mortar to bond mechanically and achieve a durable repair. Removing only 5 mm leaves insufficient bond depth and the new mortar will debond. Full depth removal risks destabilizing the wall. A fixed 10 mm depth may be insufficient for wide joints. Heritage masonry guidelines typically specify twice the joint width as the minimum removal depth for effective repointing. Question 112. What is the correct procedure for repointing mortar joints in an existing exterior brick wall? A. Rake out joints, dampen surfaces, pack new mortar in layers, and tool to match existing. B. Spread new mortar across the wall face with a trowel and scrape off the excess later. C. Fill the joints with caulking sealant that matches the color of the original mortar. D. Apply a thin coat of mortar wash over the entire wall surface to fill all the joints. The correct answer is A. Rake out joints, dampen surfaces, pack new mortar in layers, and tool to match existing. Proper repointing requires raking out the deteriorated mortar to the specified depth, dampening the joint surfaces to prevent rapid moisture loss from the new mortar, packing the new mortar into the joint in thin layers, lifts, to prevent shrinkage cracking, and tooling the final surface to match the existing joint profile. Spreading mortar across the face stains the brick. Caulking sealant is not mortar and lacks structural bond. Mortar wash, also called bagging, is a different finish technique that does not fill deep joints adequately. Question 113. What is the correct method for repairing a small spall on the face of an existing heritage brick unit without replacing the entire brick? C. Attach a thin tile over the damaged area with construction adhesive to hide the spall. D. Leave the spall unrepaired as surface damage is considered part of the building patina. Small spalls on heritage brick can be repaired in place by applying a color-matched cementitious or lime-based mineral repair mortar to the damaged area, shaping it to replicate the original brick surface profile. The repair material must be compatible with the brick in terms of hardness, porosity, and color. Wood filler is not suitable for exterior masonry. Tile overlays alter the wall profile and appearance. While patina is valued in heritage conservation, active deterioration should be arrested to prevent further damage. Question 114. When reinstalling a replacement brick in an existing wall, why must the replacement unit be dampened before setting? A. Dampening darkens the color of the new brick to better match the aged surrounding units. B. Dampening increases the compressive strength of the replacement brick by hydrating it. A dry replacement brick must be dampened before setting to prevent it from rapidly absorbing moisture from the fresh mortar, which would cause the mortar to dehydrate too quickly and result in a weak bond. When a dry brick draws water from the mortar, the cement does not have enough moisture to hydrate fully, leading to a powdery, low-strength joint. Dampening does not permanently change the brick color. It does not affect the brick's compressive strength. Dampening is necessary in all conditions, not only hot weather. Question 115. A bricklayer is asked to clean a heritage limestone building using a high-pressure water washer. What concern should the bricklayer raise before proceeding? A. High-pressure washing is the preferred cleaning method for all types of natural stone. B. The only concern is ensuring the water temperature is warm enough to dissolve stains. High-pressure water washing can erode the soft surface of limestone, damage delicate carved architectural details, and drive moisture deep into the stone, causing future freeze-thaw damage. The bricklayer should recommend low-pressure water washing with appropriate chemical cleaners specifically formulated for limestone, or gentle abrasive methods such as microabrasive cleaning. Heritage conservation standards generally prohibit high-pressure washing on soft stone. Water temperature and noise restrictions are secondary considerations compared to the risk of permanent physical damage to the irreplaceable heritage fabric. Question 116. What type of mortar is specifically recommended for installing glass block panels in masonry openings? Glass block installation requires a white Portland cement mortar with lime that is specifically formulated for glass block applications. White cement prevents gray staining of the translucent glass surfaces. The mortar must be softer and more flexible than standard brick mortar because glass blocks do not absorb moisture and have different expansion characteristics than clay or concrete masonry. Standard gray mortar stains the glass. Tile adhesive lacks structural capacity. High-strength type M is too rigid and may crack the glass. Glass block manufacturers specify compatible mortar types. Question 117. What structural component must be installed within a glass block panel to provide lateral reinforcement? Horizontal ladder-type joint reinforcement, typically stainless steel or galvanized wire, is placed in the mortar bed joints of a glass block panel, typically at every second course, to provide lateral reinforcement and resist wind loads. The reinforcement is embedded in the mortar joint and anchored to the surrounding frame or masonry. Glass blocks do not have cores for vertical rebar. Diagonal bracing is not a standard glass block reinforcement method. A perimeter frame provides support but does not reinforce the panel internally. Masonry construction standards and manufacturer instructions specify glass block reinforcement. Question 118. What preparation is required before installing precast ornamental masonry elements such as window surrounds and cornices? A. No special preparation is needed as ornamental elements are self-supporting structures. Before installing precast ornamental masonry elements, the bricklayer must verify that the structural support system, such as shelf angles or corbelled masonry, can carry the element weight, that the anchoring locations are correctly positioned per the installation drawings, and that the wall surface and alignment references are ready for precise placement. Ornamental elements are heavy and require engineered support. Pre-sealing may affect mortar bond. Paint primers are not standard preparation for masonry-to-masonry installations. Question 119. What is the correct method for installing a heavy precast concrete decorative cornice element on a masonry wall? D. Suspend the cornice from cables attached to the roof structure above the installation. Heavy precast decorative cornices must be set on a full mortar bed for even load distribution and mechanically anchored to the backup wall structure using stainless steel anchors, cramps, or dowels to prevent the element from pulling away from the wall under wind load, thermal movement, or seismic forces. Construction adhesive alone cannot support heavy precast elements. Gravity and friction are insufficient for elevated installations. Cable suspension is not a standard cornice installation method. The combination of mortar bedding and mechanical anchoring ensures both stability and load transfer. Question 120. What material is typically used to manufacture decorative masonry elements such as balusters, finials, and medallions? A. Standard concrete masonry unit material poured into simple rectangular block molds. Decorative masonry elements such as balusters, finials, and medallions are typically manufactured from precast concrete or reconstituted stone, a mix of crusite cement, aggregates, and stone dust, that is cast in custom molds to produce the detailed shapes and profiles specified by the architect. Standard CMU material is too coarse for decorative detail. Fiberglass is not a masonry material. Hand-cutting standard brick cannot achieve the complex three-dimensional profiles of these elements. Cast stone can be finished to closely resemble natural stone. Question 121. What must be verified at the arch location before building the arch template and placing any masonry units? Before arch construction begins, the bricklayer must verify that the spring points, where the arch meets the wall on each side, are level with each other, the opening width matches the architectural drawings, and the structural supports, such as the wall on each side, are ready to receive the arch thrust loads. If the spring points are not level, the arch will be asymmetrical. If the opening width is wrong, the template will not fit. Mortar color, brick count, and weather are secondary considerations that can be addressed later. Question 122. What is the correct method for building a template, centering, for a semicircular brick arch? A. Bend a sheet of plywood into a semicircle and nail it directly to the wall on each side. D. Stack loose bricks in an arch shape without a template and rely on the mortar to hold. An arch template, also called centering or false work, for a semicircular arch is built by cutting rigid plywood to the exact semicircular shape of the arch's inside radius, int, mounting it on a sturdy wooden frame, and supporting it on adjustable legs or wedges that can be lowered for removal after the arch mortar has cured. The template must accurately reproduce the specified arch curve. Bent plywood cannot maintain a precise semicircle. Inflatable forms are not standard. Building without a template produces an irregular, structurally weak arch. Question 123. Why must an arch template be supported on adjustable wedges or screw jacks rather than being fixed rigidly in place? A. Adjustable supports allow the template to be raised higher if the arch design changes. D. Fixed supports cause the template to absorb moisture and swell during the construction. An arch template must be supported on adjustable wedges or screw jacks so that it can be lowered gradually and evenly after the arch mortar has gained sufficient strength. Gradual lowering transfers the arch load to the supporting masonry progressively, preventing sudden shock that could crack fresh mortar joints. Fixed supports cannot be lowered for removal and would require destructive disassembly. The purpose is not to accommodate design changes or prevent moisture absorption. Controlled decentering is a critical step in arch construction. Question 124. When laying brick units on an arch template, what is the correct placement sequence to ensure the arch is balanced? A. Start from the left spring point and lay units across to the right spring point end. B. Place the keystone first at the top center and then work downward on both sides. C. Lay all units on one side of the arch first, then complete the opposite side after. D. Start from both spring points simultaneously and work upward to meet at the keystone. The correct answer is D. Start from both spring points simultaneously and work upward to meet at the keystone. Arch units must be laid starting from both spring points simultaneously and working upward on both sides to meet at the keystone, top center, position. This balanced placement keeps the template evenly loaded and prevents it from shifting or tipping to one side. Starting from one side only creates an unbalanced load. Placing the keystone first is structurally incorrect as it would have no support until the other units are in place. Completing one side before the other causes the template to deflect unevenly. The keystone is the last unit installed, locking the arch. Question 125. After building a brick arch, a bricklayer notices the arch has developed a visible sag when the template is partially lowered. What is the most likely cause? D. The template was built slightly larger than the specified arch radius in the drawings. A visible sag when the template is partially lowered most likely indicates that the mortar joints in the arch did not have sufficient time to cure and develop the compressive and bond strength needed to carry the arch loads independently. When the template is removed too early, the mortar cannot resist the compression forces, and the arch deforms under its own weight. Incorrect keystone placement would show immediately during construction. Wrong taper angles would prevent proper fit during laying. An oversized template would produce a slightly larger arch but not cause sagging upon removal. Thank you for practicing with Question Bank Hub. Good luck on your Bricklayer Red Seal certification exam. Don't forget to subscribe for more exam preparation content.